Hello friends, I welcome you in lecture number 9 on Laplace transform. In lecture number 8, we have discussed about first shifting theorem. So we just recall what is first shifting theorem. We know that suppose Laplace transform of f of t is say function of s denoted by capital F of s, then if we are interested in the Laplace transform of f of t, which is multiplied by exponential function e raised to at, then this Laplace transform can be obtained by replacing s by s minus a in this function f of s. So we will replace s by s minus a in f of s. That is known as Laplace first shifting theorem for Laplace transform. In this lecture also we will discuss some more applications of first shifting theorem. We find the Laplace transform of following functions. First function is 5 times e raised to 2t times sine hyperbolic 2t. So first we find out Laplace transform of sine hyperbolic 2t. And we have ready-made formula for the Laplace transform of sine hyperbolic 2t. Laplace transform of sine hyperbolic at is given by, we have seen this formula, this is given by a divided by s square minus a square, and here value of a is 2. Therefore Laplace transform of sine hyperbolic 2t is 2 divided by s square minus 2 square, or this we can rewrite as Laplace transform of sine hyperbolic 2t equals 2 divided by s square minus 4. And we are interested in the Laplace transform of this e raised to 2t times sine hyperbolic 2t. So by first shifting theorem, therefore by first shifting theorem, Laplace transform of e raised to 2t, let me check, function multiplied is exponential function e raised to 2t times sine hyperbolic 2t is obtained by replacing s by s minus 2. In this function we will replace s by s minus 2 because coefficient of t is 2 here. So this we can obtain by replacing s by s minus 2 in this Laplace transform of sine hyperbolic 2t, and we can simplify this. This is equal to, we can expand this square of s minus 2, that is s square minus 2 times 2s, that is minus 4s plus 4 and minus 4. Therefore Laplace transform of e raised to 2t times sine hyperbolic 2t is equal to 2 times d2 divided by s square minus 4s. This 4 will cancel out, and we have constant 5 in the product. So by linearity property, therefore Laplace transform of 5 times e raised to 2t sine hyperbolic 2t equals 5 times Laplace transform of e raised to 2t times sine hyperbolic 2t, and that is equal to 5 into this function 2 divided by s square minus 4s, that is 5 into 2, 10 divided by, we can take s common and we can write in this form also, 10 divided by s times s minus 4. So this is very easy, we just have to find out the Laplace transform of the function which is multiplied with exponential function, and whatever Laplace transform we obtain for that function, we have to replace s by s minus a in that function. We consider another function. Here function is e raised to minus t cos square t by 2, and if we wish we can rewrite this as e raised to minus t times 2 times cos square t by 2. So first we have to find out Laplace transform of this function 2 times cos square t by 2. For that we recall this formula. We know that 2 cos square theta is given by 1 plus cos 2 theta. So whatever angle is here, that angle we have to double here. Here angle is t by 2. Therefore if we replace theta by t by 2, this is going to be 1 plus cosine of 2 times t by 2, that is 1 plus cos t. So we will replace this function 2 cos square t by 2 by this 1 plus cos t. So this I can rewrite as e raised to minus t times 1 plus cosine of t, because I don't have the formula for the square of cosine function. We don't know we don't have the standard formula for the Laplace transform of cos square function, but we are having the formula for the Laplace transform of cos function. Therefore we have converted this function cos square in terms of cos function. Now first we find out Laplace transform of this function 1 plus cos t, and for that we use linearity property. This is equal to Laplace transform of 1 plus Laplace transform of cos t by linearity property, and we know that Laplace transform of 1 is given by 1 by s. Laplace transform of cos at is s divided by s square plus a square. Here a is 1, so 1 square, that is 1, and this we can simplify by taking LCM. LCM is s times s square plus 1, and here we have s square plus 1 plus s into s, that is s square, and this again we can rewrite as 2s square plus 1 divided by s times s square plus 1. So therefore Laplace transform of 2 times cos square t by 2 is this function of s. And now we consider Laplace transform of e raised to minus t times 2 cos square t by 2, that we will write by first shifting theorem. Therefore by first shifting theorem our function is multiplied with e raised to minus t. Laplace transform of e raised to minus t 2 cos square t by 2 is obtained by replacing s by s minus coefficient of t, which is minus 1 here, that is s minus minus 1, that is s plus 1. So we will replace s by s plus 1 everywhere in this function, that is 2 times s plus 1 square plus 1, s plus 1 times s plus 1 square plus 1. Replace everywhere in this function, replace s by s plus 1. So we have s at 3 places, and at all the 3 places we replace s by s plus 1, and then we can simplify this. This is 2 times s square plus 2s plus 1 plus 1, this s plus 1 as it is, and here also we expand square of s plus 1, s square plus 2s plus 1 plus 1, and here this we can multiply by 2. So we have 2s square plus 4s plus 2 and plus 1, that we directly write as 3, and here s plus 1 as it is, s square plus 2s plus 2. So this is Laplace transform of e raised to minus t times 2 cos square t by 2, or Laplace transform of 2 times e raised to minus t cos square t by 2. So this is another application of first shifting theorem. We are first finding Laplace transform of this function, which is multiplied by exponential function, and we replace s by s plus 1 in the Laplace transform of this function to obtain the Laplace transform of e raised to minus t times 2 cos square t by 2. Third function is sin hyperbolic t cos t, and here there is no exponential function, but we can convert it in terms of exponential function. We know this formula for sin hyperbolic at. It is defined as e raised to at minus e raised to minus at divided by 2. This is the definition of hyperbolic sine. Here instead of sin hyperbolic at, we have sin hyperbolic t. So, and value of a is 1. So first we rewrite sin hyperbolic t as e raised to t minus e raised to minus t divided by 2 times cos t. So this we can rewrite as 1 by 2 constant, and this is e raised to t times cos t minus e raised to minus t times cos t. So for this we require the Laplace transform of cosine function, and we know that Laplace transform of cosine function is s divided by s square plus a square, that is s divided by s square plus 1. Therefore, by first shifting theorem, we have to mention whatever result we are using. By first shifting theorem, we write down left hand side sin hyperbolic t times cos t, Laplace transform of sin hyperbolic times cos t equal to 1 by 2 times, first we write Laplace transform of e raised to t cos t minus Laplace transform of e raised to minus t cos t by linearity property. Laplace transform of e raised to t cos t minus Laplace transform of e raised to minus t times cos t. This 1 by 2 is multiplication of this whole bracket. Now here in e raised to t, coefficient of t is 1, so we will replace s by s minus 1. For e raised to t cos t, here coefficient of t is 1, so for first shifting theorem, s will be replaced by s minus 1. So first we write down Laplace transform of e raised to t cos t, which is s minus 1 divided by s minus 1 square plus 1. In this Laplace transform, we have replaced s by s minus 1. For second part, coefficient of t is minus 1, so we have to replace s by s minus minus 1, that is s plus 1. So here in this function we have to replace s by s plus 1 for this Laplace transform of e raised to minus t cos t. So this is s plus 1 square plus 1. So now we can rewrite all these things. 1 by 2, this is s minus 1. Here if we expand this, we have s square minus 2s plus 1 and plus 1, that we can directly write as 2. And the same thing here, s plus 1 square of s plus 1 is s square plus 2s plus 1, that is 2. And then we can again take LCM, and we can rewrite this function in nice form if it is possible. S square plus 2s plus 2, and here we write product of these two, s minus 1 times s square plus 2s plus 2 minus s plus 1 times s square minus 2s plus 2, and this is equal to 1 by 2 times we keep LCM as it is, s square minus 2s plus 2 s square plus 2s plus 2. First we multiply this bracket by s, and we have s cube plus 2s square plus 2s. This is multiplied by s cube plus 2s square plus 2s. Then this is multiplied by minus 1, so we have minus s square minus 2s minus 2. Now first we multiply this by s, but we have negative sign, so we have to be careful. We will obtain s cube, but we have negative sign, so we will write minus s cube. Here we will have minus 2s square, and due to negative sign it will be plus 2s square. Then we have 2s, but due to negative sign it will be minus 2s, and again this is multiplied by minus 1, so we have minus s square plus 2s minus 2. Now we again simplify this, we cancel out terms which are possible to cancel out, and denominator remains as it is, s square minus 2s plus 2 s square plus 2s plus 2, and we can observe that s cube will cancel out. Then we have minus s square, that is minus 2s square, that will cancel out with this 2s minus 2s will cancel each other. Similarly 2s minus 2s will cancel each other, and we are left with this 2s square. So this we have written, and minus 2 minus 2, that is going to be minus 4. And finally we can take this 2 common from the numerator, and we are left with s square minus 2, and here s square minus 2s plus 2 s square plus 2s plus 2, and if you can understand, we can directly cancel out these 2 and with these 2. So this is the Laplace transform of sin hyperbolic t cos t. If we wish, we can still further simplify. We can use the formula for this using a plus b into a minus b, s square minus 2. If we observe here, we have s square plus 2 plus 2s, and s square plus 2 minus 2s, s square plus 2 plus 2s, and s square plus 2 minus 2s. So we can further simplify if we wish. This is going to be square of s square plus 2 minus square of 2s, using the formula of a plus b times a minus b, and this is s square minus 2. If we expand this, this is going to be s raised to 4 plus 4 times s square plus 4 minus 4 times s square, and we can observe that 4s square will cancel out, and we are left with s square minus 2 divided by s raised to 4 plus 4. So we obtain this nice form after simplifying all these things. So depending upon the weightage of marks, you have to decide that how far you should go, and sometimes they can ask you that show that Laplace transform of this function is given by this s square minus 2 divided by s raised to 4 plus 4. So in that case you have to go up to this step. Okay, sometimes they can ask you to prove this type of Laplace transforms. Prove that Laplace transform of sin hyperbolic t cos t is given by s square minus 2 divided by s raised to 4 plus 4. So in that case you have to prove up to this. You must simplify unless you get this expression for Laplace transform of this function. So in this way, this first shifting theorem is helpful if our function is multiplied with exponential function. So this is all about this session. I hope you like it. Thank you very much.